morning, all. So I'd like to start this session here with a question, and that is, why open computing? Why is this actually important, and why we should invest in it? And it really comes down to one key word, developers. If you pick out, for instance, Linux as arguably the most successful, one of the largest open source projects in the world, it has a massive amount of variation, innovation, but more importantly, in today's society, it's still auditable and secure. If it isn't secure, it can be made secure. There are a lot of eyes looking at the source code and making sure that vulnerabilities, bugs, et cetera, get patched very rapidly. But what really powered the rise of Linux and related systems? Really, if you look at the history, it's the fact that there were actually open hardware platforms on which this work could actually happen. You had unfettered access to documentation in many cases, massive collaboration, especially with the rise of the internet, but this has enabled something relatively new, we'll call needs-based development, literally creating software from the pieces that exist to actually fulfill a specific need, instead of trying to shoehorn an existing application into a role it may or may not be suited for. So, coming back to the concept of open platforms, those open platforms, owner-controlled hardware, they actually enable innovation on a scale that we really haven't seen recently. When open hardware becomes unavailable for whatever reason, you actually see new players come in, try to create new open platforms to fill the void. You look at ARM to a certain extent. I mean, ARM is older, but it really came back out of the shadows and is now a dominant player in the world. You look at something new, RISC-V, and now especially, and this would not have been predicted 5, 10 years ago, we have OpenPOWER, and it's really coming and filling a void that has existed over the past few years. Fundamentally, we're looking at the choice between local control or central control. Now, history, repeatedly has shown that some degree of local control is still required. Central control stifles innovation over time. Now, with the computing systems the way they are, local control is currently perceived as too complex for users. And really, I would challenge that. Is local control really that complex? Is that something that the average user can't use an existing open source program, platform, cloud provider to really retain control of their computing, but at the same time offload a lot of the drudgery, the day-to-day work, the development to the larger community? And cloud these days, it's really a new paradigm. It's a recycling of the older concept of a central system, but with a number of changes. You really see a shift to open source for the infrastructure and the actual applications in the cloud sphere. You see the cloud providers really relying more on their platform, their hardware, whatever unique backend advantages they have, and really embracing the concept of open source for the application stack. You have this interesting idea of being able to develop locally on a platform that's actually compatible with your remote cloud system, or even vice versa. If you need more compute resources in the cloud to do the development, you can deploy locally to other systems. However, all this power comes with a certain risk. It brings new challenges. One of the major ones is actually the trustworthiness of cloud systems. How do you actually guarantee that your application running on someone else's computer that you've never met and you have no service level agreement or anything along those lines with, how do you guarantee that your application is actually executing in a secure environment, it hasn't been tampered with, and it isn't being controlled essentially outside of your wishes? And this is an area where open hardware becomes incredibly important. How do you solve the bidirectional trust problem? How do you trust the cloud provider and the cloud provider trust you? So one of the easiest ways to accomplish that is to have hardware and software and firmware that is open for all parties to inspect, all parties to look at for vulnerabilities, and to collaborate to seal them off and agree on the actual hardware being trustworthy, firmware being trustworthy, and software being trustworthy. And this is actually something where Raptor's been working on technology now for a couple of years. Literally a distributed, client interactive trust attestation system. It's built on something we call the FlexFair module. And this is actually live right now on one of our demonstration cloud platforms. We call it FlexSphere, and it's something that'll be coming probably for the OpenPOWER systems next year. So, stepping back for a bit, Raptor and IBM have been working together for some time. We've been enabling the development community in ways that haven't been seen really for many years. IBM obviously brought the first performance competitive, and power competitive, open, owner-controllable CPUs since about 2013. That's be the Power 8, and now obviously the Power 9. Really an industry first, we have, at least for the past decade, we have full source, we have full documentation for the processor. And this is all the way down to the code that's running literally on the onboard management processors. If you have anything you want to change configuration-wise on that processor, you have the ability to do so with OpenPOWER systems. Raptor brought the first widely available low-cost Power 9 hardware to market. That's our Talos 2 systems right now. That's up to 44 cores a system, or we can go all the way down to 4 cores per system. And more importantly, we're building this all on a standard hardware platform. We don't want to get into proprietary modules, proprietary add-ons, where there's already an existing system, existing standard that fulfills the needs. So you'll see all of our products are talking ATX, eATX, things along those lines and using standard memory modules to make it as easy to use a power system as it would be to use an equivalent x86 box. One of the other really important things here that OpenPOWER does that hasn't really been seen in other competing architectures is that there's actually a certification process to make sure that the hardware is compliant. What that means is that you don't have the same ecosystem fracturing that we've seen before, where you build one binary here, you build one here, and they don't run on the system for whatever reason. So we're literally at the point here where the same kernels can run on Power 8, that run on Power 9. There's some backward compatibility there. The same software applications will run. So literally, if you have a Power 8 or higher executable, it will likely run on not only Power 9, but future Power platforms. Compare and contrast that with a couple of the current competing options, and you can see that there's a significant advantage there. So what's next? Obviously, we need further ecosystem expansion. Right now, everyone's offerings primarily focus on supercomputing. They focus on professional developers, people with essentially a lot of resources at their disposal. There are obviously exceptions, but that has been the general trend. There are obviously existing commodity Power 9 servers, workstations, but again, these are for higher-end applications. There's really a need for what we call target machines or deployment machines. These are the systems that the average person would be able to use and use the OpenPOWER applications. Maybe even do some basic development on, depending on the size of the project. This would be able to empower smaller developers and bring open systems back to the desktop sphere. Looking to bring open systems back to the desktop. And we did so. This is our brand new platform, the Blackbird system. It's the world's first OpenPOWER desktop / network appliance system. It's built on the micro ATX form factor, so you're not talking a gigantic server board. You're talking something that's much smaller and much more suited for actual desk-side use. It's lower power, lower cost, and basically a perfect companion to the Talos 2. In an ideal world, you would do your development of something like a Talos 2, someone's remote cloud system, or a small project even on something like this, and actually deploy that software to a machine or multiple machines that are desk-side for people that want to use your application. So what's next after this? We actually have a long way to go. We need to continue working toward additional open system components. Obviously, as many of you know, we've let a lot of the standards on open platforms kind of slide. We have GPUs, we have SAS controllers, we have FPGAs, we have almost every single peripheral, USB controllers, that requires, in many cases, signed closed firmware in order to run. And that's in direct conflict with the concept of an open, auditable, and securable system. So over time, we want to see these components open up. We want to see the GPU to actually be able to be a trusted compute element like the CPU instead of what it is right now, and that is a kind of a black box that probably should not be trusted for highly sensitive computations. We want to continue expanding the OpenPOWER software ecosystem. Some of the things that both Raptor and the general community have done over the past couple of years, that FreeBSD was brought to the OpenPOWER platform. We actually have the Chromium browser from Google that is operational on the Power systems, and trying to engage Google to actually merge that upstream. And on a different note, we actually were able to bring over the Unreal Engine 4. This is a AAA game engine from Epic Games, and it actually runs very well on Power. Power is an interesting development platform for such things. So we actually have a demo of Unreal Tournament 4 running on this at our booth. So in conclusion, we have what I would call a second open computing revolution underway. The first one obviously could arguably be called the original PC. The fact that there was a standards compliant system in which not only software developers but hardware manufacturers could build compatible systems, and we saw massive growth and innovation from that. Right now what's going on, this is driven by very similar forces. The technology is vastly different. But you can see the results. We have rapid growth in the overall OpenPOWER ecosystem. Some of that is attributable to our machines. You can actually see a bump, if you're curious, on the Debian popularity contest, literally from about the time that our machines were really shipping in earnest for the first time. And really what we're seeing is developers relearning the idea that open systems are the best for innovation. We have people literally that tell us that they have not had this much fun with a computer in years, that they're actually able to sit down, that they're actually able to do their work, they're able to concentrate on what they want to see done instead of fighting with the technology. For all the developers out there, your support is key. We're the ones that fundamentally choose the platforms that the public will adopt. So what kind of computing systems do you want to see in the world 10 years from now, 20 years from now? Thank you all.